Every reflection you have ever seen of yourself was a lie. Not a metaphor, not a philosophical idea. A literal, physical lie built from the most bizarre element on the periodic table. And the moment you understand what is actually happening when you look at your own face in a mirror, you will never stand in front of one the same way again. Let me start with water. Not a mirror, not polished glass, just a puddle. A still, dark puddle on a cobblestone street after rain. The kind that reflects a gray sky so perfectly you almost feel like you could fall into it. Humans used surfaces like this for thousands of years before we figured out how to make anything better. A bowl of water, a piece of obsidian, a sheet of polished bronze that gave back a dim, orange, smudged version of your face. For most of human history, nobody really knew what they looked like. Not clearly, not truly. The image was always murky, always distorted, always a little wrong. Then came the moment when everything changed. A thin, almost impossibly thin, layer of a single metal was applied to the back of a piece of glass, and suddenly the world could see itself with perfect clarity for the first time. That metal was not gold. It was not platinum. It was not some rare laboratory curiosity. It was silver, element 47. The element that most people associate with second place, with cheap jewelry, with the runner-up trophy. And yet it is the only substance in nature that can do what it does to light. No other material even comes close. Here is what nobody tells you. When light hits a silver surface, something happens that breaks the intuitive logic most people carry around in their heads. You would expect a shiny metal to simply bounce light back the way a wall bounces a ball. But that is not what silver does at all. Silver does not passively reflect anything. Silver actively refuses the light. It rejects it. With a ferocity, with an efficiency so extreme that 99 out of every 100 photons that reach its surface are thrown back into space without being absorbed. What you see when you look in a mirror is the light that silver decided it did not want. Your face, your eyes, the shadows under your cheekbones, all of it is the rejected portion. The trash, the leftovers of a metal that is, at the quantum level, one of the most hostile and closed-off substances in existence. And the reason this rejection is so perfect comes down to something that physicists call plasmonic resonance, which sounds complicated, but is actually a beautifully simple idea. The electrons on the surface of silver do not behave like individual particles. They move together, like a single fluid, like an ocean that ripples all at once when something touches it. When a photon arrives, the entire electron ocean responds as one. It rises, it pushes back, and the photon has nowhere to go except back the way it came. Silver is not a mirror because it is shiny. Silver is a mirror because its electrons are essentially a collective intelligence that refuses entry to everything. Think about that for a second. The clearest image of yourself you have ever seen was produced by a material that was, at the atomic level, completely rejecting your existence. The more hostile the host, the more perfect the reflection. There is something deeply strange about that. Something that makes you look at the gleaming surface of a mirror with a slightly different feeling once you know it. And here is where it gets even stranger. That layer of silver on the back of your bathroom mirror is not thick. It is not a sheet of metal. It is a coating so thin that if you tried to scrape it off with your fingernail, it would crumble into a gray powder with no shine, no reflectivity, nothing. 500 atoms thick, that is all. Thousands of times thinner than a single strand of human hair. 500 atoms standing between you and a completely transparent piece of glass that would show you nothing but the wall behind it. The most perfect optical instrument that human civilization has ever mass-produced is held together by a layer of metal so fragile it barely exists. If that does not make you stop and stare at your reflection with a little more respect, I do not know what will. But trust me, by the time we finish this story, the mirror is going to be the least surprising thing about silver. Friends, if you find this as mind-bending as I do, hit subscribe and leave a like. It genuinely helps more than you might think, and there is so much more to come. Now, the mirror trick is impressive, but the mirror is just one party trick in a very long and very strange list of things that silver does that no other element can replicate. And to understand why silver behaves like a physical anomaly, you need to understand something about how most metals work. And then you need to understand why silver breaks every single one of those rules. Pick any common metal: iron, copper, aluminum. When an electric current flows through these materials, the electrons move, but they move with resistance. They bump into the crystal structure of the metal, they scatter, they lose energy, and that lost energy becomes heat. This is not a flaw in the design. This is just physics. Resistance is the price you pay for moving charge through matter. Every engineer on the planet accepts this as a fundamental constraint. You build your systems around it. You add cooling. You oversize your cables. You accept the waste. Then there is silver. When electrical engineers first measured the conductivity of silver against a standardized scale, the scale was built around copper, which at the time was considered the gold standard of electrical performance. Copper was set at 100%. That was the ceiling. That was the best that nature had to offer. When they ran the same measurement on silver, the number that came back was 106. Silver does not fit inside the standard that humans built to measure excellence. It exceeds it before the test is even finished. Gold, by comparison, the metal that entire civilizations have worshipped, that has been used as the ultimate symbol of value and perfection for thousands of years. Gold sits at around 70% on that same scale. From a pure physics standpoint, gold is a mediocre conductor. It is slow, it is heavy, it resists current. The only reason it appears in high-end electronics at all is because it does not corrode. Not because it performs well, but because it does not rot. Gold is a material we use when we need something that survives, not something that excels. Silver is what we use when we need something that actually works. And the thermal conductivity of silver is just as extreme. If you want to understand what it feels like to touch a material that moves heat faster than almost anything else in the natural world, imagine placing your hand on a surface and feeling the warmth drain out of your palm in a fraction of a second. Not because the surface is cold, but because it pulls heat away so efficiently that your body cannot keep up. Silver does not just conduct electricity. It conducts energy of almost any kind with a speed and ease that feels like the material has no interior resistance at all, like there is simply nothing inside it to slow anything down. So why do we not use it everywhere? Why is the wiring inside your walls copper? Why are the cables under the ocean copper? Why do server farms run on copper and aluminum and accept the heat and the waste and the cooling costs? The answer is one word: price. Silver is expensive. Not because it is rare in the absolute sense, but because the supply is limited and the demand is enormous. And so we made a civilizational choice, quietly, without a vote, without a debate. We decided that the cost of using the best tool was too high, and we built our entire technological world on the second best option instead. Every time your laptop gets warm on your legs, every time a power station loses a fraction of its output to heat before it ever reaches your home, that is the sound of that decision echoing forward through time. But the truly strange thing about silver is not that it conducts better than everything else. The truly strange thing is why. And the reason takes us somewhere that has nothing to do with engineering at all. It takes us back to before the Earth existed. Back to a moment so violent that describing it feels almost irresponsible. Because silver did not form here. It did not come from our sun. It did not come from any ordinary star. It came from something else entirely. Something that makes a supernova look like a flickering candle. And that origin story changes everything about how you think of this metal. Gold has been lying to you your entire life. And the worst part is that we all agreed to believe the lie together, collectively, without anyone forcing us. We built museums around it. We wrote laws protecting it. We started conflicts over it. We literally reshaped the surface of the planet to dig it out of the ground. And for what? For a metal that, when you strip away every cultural story ever told about it, is physically slower, weaker, and less capable than the element sitting quietly in second place on every price tag in every jewelry store in the world. Let me give you a number that I still think about whenever I hold a coin in my hand. When engineers built the international standard for measuring electrical conductivity, they needed a reference point, something to call 100%, the best available, the ceiling. They chose copper, which at the time was considered the finest practical conductor that industry could work with. Copper was the benchmark, and for a while that felt correct. Copper wired the first cities. Copper carried the first telephone calls. Copper connected the first light bulbs to the first generators. It felt like the pinnacle of what nature had to offer. Then someone measured silver against that same scale. The result was 106, not 99, not 101, 106. Silver does not approach the ceiling, it walks straight through it. The standard that humans designed to represent the absolute best that conducting matter could do was not enough to contain what silver actually is. Now measure gold on that same scale. The metal that emperors hoarded, that explorers crossed oceans to find, that investors still treat as the safest store of value on Earth. Gold scores around 70% of what copper can do, less than 2/3 of what silver can do. From a pure physics standpoint, gold is not a premium material. It is an underperformer wrapped in thousands of years of very effective storytelling. The reason gold survives in modern electronics at all is a single property that has nothing to do with performance. Gold does not corrode. It sits there, inert, unchanging, chemically indifferent to everything around it. You can leave a gold contact exposed to air for a century and it will look exactly the same. That stubbornness is useful in very specific, very delicate applications, like the connectors inside a processor that need to stay clean across millions of cycles. But useful for that narrow purpose is not the same as superior. Gold is the material you reach for when you need something that will not fail. Silver is the material you reach for when you need something that will actually excel. And here is the part that starts to feel genuinely uncomfortable when you sit with it. We wired the entire planet with copper because silver was too expensive. We accepted a global infrastructure built on a compromised material. Every power line stretched across every landscape you have ever driven through. Every cable buried under every city street. Every wire running through the walls of the building you are sitting in right now. All of it is copper. All of it is generating heat it should not be generating, losing energy it should not be losing, humming with a low inefficiency that we have simply normalized because the alternative cost more money. The heat your devices generate is not a technical inevitability. It is an economic choice that was made for you before you were born. The energy that vanishes between a power station and your home is not an unsolvable physics problem. It is the price of a decision that prioritized budget over performance, and then handed that decision down through generations until it became invisible. We stopped questioning it. We started calling it just the way things work. Silver knew better all along. It just never got the cultural mythology that gold did. Nobody wrote poems about it. Nobody built temples to it. It sat there at 106%, doing its job perfectly, quietly outperforming everything around it, while the world threw parades for the metal sitting 36 points below it on a scale that silver itself had already broken. But here is the thing about silver that the conductivity numbers do not fully capture. The reason it performs the way it does, the reason its electrons move with that almost frictionless freedom, goes much deeper than crystal structure or atomic weight. It goes all the way back to the conditions that created silver in the first place. And those conditions are so extreme, so far outside anything that happens in ordinary stellar physics, that understanding them will permanently change the way you think about every piece of this metal you have ever touched. Because silver did not come from a star like our sun. It did not come from any star that ever burned steadily and calmly in the night sky. It came from something else. Something that makes the death of a star look like a minor disturbance. And the story of how it got here is, without exaggeration, the most violent origin story of any material that has ever passed through human hands. Our sun is a stable middle-aged star that has been fusing hydrogen into helium for about 4.5 billion years. It is good at this. It will keep doing it for several billion more. But there is a hard ceiling on what a star like ours can build. Nuclear fusion inside an ordinary star can produce elements up to iron, and then it stops. Iron is where stellar fusion hits a wall. Fusing iron does not release energy, it costs energy. So the star reaches iron and essentially runs out of road. It cannot push further up the periodic table. It was never designed to. This means that every element heavier than iron, every single one, including silver, cannot be made inside a star like the sun. It requires something categorically different. Something that happens only in the most extreme conditions the universe ever produces. And for a long time, scientists thought they knew what that was. They pointed to supernovae, to the explosive deaths of massive stars, as the forge that produced heavy elements. The energy of a collapsing stellar core, they reasoned, should be enough to drive the rapid neutron capture process that builds atoms heavier than iron. And supernovae do contribute. But the numbers never quite added up. The amount of silver we find in the universe, the distribution of it, the quantities, never matched what supernovae alone could explain. Then the gravitational wave detectors came online, and in one observation, everything changed. Scientists detected a signal rippling through space-time itself, a distortion in the fabric of the universe produced by a collision so energetic that it briefly outshone entire galaxies. Two neutron stars had found each other. And the light that followed told researchers something they had suspected but never confirmed. The collision of two neutron stars produces more silver in a single event than our sun will ever be capable of producing across its entire lifespan. Not more than it produces in a year, more than it will produce across billions of years of burning. A neutron star is not a large object by astronomical standards. It is roughly the size of a major city, but it contains more mass than our entire sun compressed into that small space. The density of matter inside a neutron star is so extreme that ordinary atoms cannot exist there. Protons and electrons are crushed together into neutrons packed so tightly that a single spoonful of neutron star material would weigh more than every mountain range on Earth combined. When two of these objects spiral toward each other, drawn together by gravity over millions of years, the final moments of their approach are almost impossible to describe. They accelerate. They spin faster and faster around each other, closer and closer, and in the last seconds before impact, they are moving at a significant fraction of the speed of light. The collision that follows is called a kilonova. It releases more energy in that single moment than our sun will release across its entire existence. And in the chaos of that collision, in temperatures that dwarf anything a supernova can produce, neutron-rich material is ejected outward at tremendous speed. Inside that ejected cloud, rapid neutron capture builds heavy elements from scratch. Atoms are assembled from pure energy and pressure in fractions of a second. Silver forms. Gold forms. Platinum forms. The entire lower section of the periodic table is minted in one catastrophic transaction. That cloud expands outward into space. It cools. It drifts. Over millions of years, it mixes with other gas and dust. It collapses under its own gravity into new systems, new planets, new worlds. And some of that material, the shrapnel of a stellar collision that happened long before our sun ever ignited, ended up here, in the crust of this planet, in veins of rock deep underground, in the ore that human hands eventually learned to dig out and refine. Every piece of silver on Earth is older than the Earth itself. It arrived here from outside, carried in the debris of a catastrophe so large it bent space-time around its epicenter. The ring on your finger, the contacts inside your phone, the thin coating on your bathroom mirror, all of it was forged in a collision between dead stars before our solar system even existed. You are not holding metal. You are holding a fragment of one of the most violent events the universe has ever produced. And here is what that origin explains about everything we talked about before. The reason silver conducts the way it does, the reason its electrons behave like a synchronized fluid rather than independent particles, comes directly from the quantum architecture that was locked in during those extreme formation conditions. The element arrived in this solar system already tuned, already optimized at the atomic level in ways that no chemistry on Earth could have produced. It did not evolve here. It was delivered here, fully formed, from a place and a process that our sun could never replicate. Which makes what happened next, once humans found it and started pulling it out of the ground, feel all the more significant. Because the story of what we did with silver once we had it in our hands is not a story of wisdom or reverence. It is a story of something much darker. And it starts with a poison. The most expensive objects in Renaissance Europe were built on the suffering of people whose names nobody ever recorded. And the metal at the center of that transaction was silver, not gold, silver. The shrapnel of dead stars that we talked about, the element that outperforms every conductor on the periodic table, the substance that arrived on this planet from a collision older than the sun itself. Once humans understood its value, they pursued it with a hunger that left a trail of destruction so vast it altered the chemistry of the atmosphere across an entire hemisphere. Let me take you to a specific place, a mountain in the Andes, sitting at an altitude so high that the air there is thin enough to make your head spin within minutes of arriving. The locals who lived near it had a name for it that translated loosely as the mountain that eats men. They were not speaking in metaphor. Inside that mountain was one of the largest concentrations of silver ore ever discovered on Earth. When the Spanish colonial administration realized what they had found, they built an entire city at the base of it, almost overnight. At its peak, that city was larger than London. It was one of the wealthiest places on the planet, and it ran entirely on forced labor, on people brought from surrounding regions who had no choice in the matter, driven into tunnels so narrow that two people could not pass each other, breathing air thick with mineral dust, working by candlelight in a rock so rich with ore it almost glittered in the dark. But the real horror was not the tunnels. It was what happened to the ore once it came out. The silver in that rock was not pure. It was locked inside stone, bonded to sulfur compounds, invisible to the naked eye, and impossible to separate by heat alone at the scale they needed. So they invented a process. They crushed the ore into a fine gray powder, mixed it with salt and with liquid mercury, and spread it across large open courtyards. Then they sent workers in to walk through it, for days at a time, barefoot, wading through a toxic mixture, churning it with their feet so that the mercury could react with the silver and pull it out of the rock. The mercury bonded to the silver, forming a thick amalgam that could then be collected and heated to drive the mercury off, leaving pure metal behind. What happened to the workers is not difficult to imagine. Mercury moves through skin. It does not stay on the surface. It enters the body and it accumulates, and it does its damage slowly, in stages. Tremors start first. Then the teeth begin to loosen. Then the mind begins to slip. The process took months, sometimes less. A worker who arrived healthy could be unrecognizable within a season. Conservative estimates from historical records suggest that over the full span of that operation, across roughly 3 centuries of continuous extraction, the number of people who lost their lives to that mountain and its methods reached into the millions. That is not a rounding error. That is a number that belongs in the same conversation as the great catastrophes of human history. And at the other end of the supply chain, an ocean away, the silver that came out of that mountain was being poured into the finest homes in Europe. It sat on dining tables in the form of candlesticks and serving dishes. It hung on walls as decorative plates. It filled the treasuries of kings and funded the construction of cathedrals and universities and the early institutions of what we now call modern civilization. The Renaissance, with all its art and philosophy and scientific inquiry, was financed in significant part by the revenue flowing out of that mountain. Every painting hanging in a European museum from that era exists in a world made possible by what happened inside those tunnels. You cannot separate the beauty from the cost. They are the same transaction. And here is the piece that history books tend to skip over quietly. The aristocrats who commissioned those paintings, who ate from those silver dishes, who drank from those silver cups every single night, were not untouched by the metal either. Just more slowly and more gently, and in a way that looked from the outside like refinement rather than damage. But we will get to that, because the way silver interacts with the human body is its own story, and it is one of the strangest and most unsettling things about this element. What matters right now is the pattern. Silver arrives on this planet as shrapnel from a cosmic catastrophe. It buries itself in rock, bonded to some of the most toxic companion elements in the periodic table, as if it does not want to be found. And when humans find it anyway and begin to extract it, the process of doing so leaves a mark on the land, on the air, on the people involved. Silver does not give itself up easily. It never has. And the methods we have used to take it have always had a price attached that rarely appeared on any official ledger. But here is what makes this element so endlessly complicated and so impossible to simply condemn. The same silver that came out of those mountains and cost so much to obtain went on to do something that no other material in history has ever done. It learned to hold memory. Not metaphorically, literally. It learned to capture a moment in time, a specific arrangement of light, and freeze it in atomic structure so that it could be looked at again 100 years later. Silver became the foundation of photography. And the way it does that is so strange and so precise and so deeply connected to the quantum behavior we already talked about, that it feels less like chemistry and more like a trick the universe is playing on us. To understand it, you have to go back to those free electrons, that collective fluid on the surface of the metal that we talked about when we were discussing mirrors and conductivity. That same electronic sensitivity, that same hair-trigger responsiveness to incoming light, is what makes silver halide crystals the perfect material for capturing an image. A silver halide crystal is essentially a quantum mousetrap. It sits in a stable state, waiting. And when a single photon of light arrives and strikes it, the energy of that collision is enough to knock one electron free from its orbit. That free electron drifts through the crystal lattice until it gets caught in a microscopic imperfection, a tiny structural defect, and there it sits. And that single trapped electron is enough to attract a silver ion, which snaps into place beside it and converts into a single atom of metallic silver. One atom, in a crystal containing billions. That is the beginning of a photograph. You cannot see it. The film looks completely unchanged. If you pulled it out of the camera and held it up to the light, you would see nothing but a dull, translucent strip. But at the atomic level, a map already exists. Wherever light fell on the surface, tiny clusters of silver atoms mark the spot, invisible to the eye but physically present, encoded into the structure of the material itself. Physicists call this the latent image, the hidden picture, the ghost that exists before it has been shown. The developer does not create the image, it reveals what is already there. The chemical finds those seed clusters of metallic silver, those spots where light made its mark, and uses them as a starting point for a chain reaction. Around each cluster, the entire surrounding crystal converts from transparent salt to opaque black metal. Fast and completely and irreversibly. The areas where light fell become dark. The areas where no light reached stay clear. And the combination of those dark and clear regions, assembled across millions of crystals on a strip of film, becomes a face, a landscape, a moment in time that would otherwise be gone forever. Now think about what you are actually holding when you look at an old photograph. The dark areas, the shadows that form the outline of a person's eyes, the silhouette of a building against a pale sky, those are pure metallic silver, rearranged from their original crystalline state into a pattern that imitates the world. A photograph is not a picture. It is a thin layer of metal that was reorganized by light to remember what the light looked like. Every black and white image ever taken is, at its core, a silver sculpture of a moment. And every person whose face appears in those images left a physical trace of themselves in the atomic structure of the film. They are in there, literally, in the metal. But here is the part that unsettles me every time I think about it. That trace is not permanent. Silver halide chemistry is not stable. Even in a sealed archive, even in complete darkness, those crystals continue to slowly react. The metal is always trying to return to a more disordered state. The image is always fading, always losing resolution, always moving. Atom by atom, back toward chaos. The oldest photographs in the world are slowly dissolving. The faces in your grandparents' albums are gradually losing definition. Silver remembers, but it does not remember without limit, and it does not remember without cost. And the way it forgets is the same process that makes it one of the most dangerous substances you can put inside your own body. Silver kills bacteria so efficiently that a single coin dropped into a container of water will keep it drinkable for days without any other treatment. No filter, no chemical, no heat. Just the metal sitting there, slowly releasing ions into the water, and quietly eliminating anything biological that tries to grow in it. People knew this was happening long before anyone understood why. Roman soldiers carried silver vessels on campaigns. Nomadic traders stored drinking water in silver-lined containers that crossed deserts without spoiling. Medieval physicians packed wounds with thin sheets of the metal and watched infections clear that would have cost a limb or a life under any other treatment available at the time. They could not explain the mechanism. They just knew it worked. And the mechanism, when we finally understood it centuries later, turned out to be one of the most precise and ruthless biological processes that chemistry has ever produced. Here is what actually happens when a silver ion encounters a living bacterial cell. The ion carries a positive charge, and the surface of a bacterial cell carries a negative charge. So the attraction between them is immediate and strong. The ion does not wait for an invitation. It binds to the proteins on the outer membrane of the cell and starts pulling them apart, breaking the chemical bonds that hold the membrane together. Small gaps open up. The cell begins to leak. Its internal chemistry starts to spill outward, while the surrounding environment floods inward. For a cell that depends on precise internal conditions to function, this is catastrophic. But it is only the beginning. Once silver ions breach the membrane, they move inward and find the respiratory machinery of the cell. The proteins responsible for processing oxygen and generating energy. They bind to the sulfur atoms in those proteins and lock them in place. The machinery stops. The cell is surrounded by nutrients and oxygen and cannot use any of it. It is like being sealed inside a room full of food and air with your lungs and stomach physically unable to function. The cell begins to suffocate from the inside, while the resources it needs sit untouched all around it. And then silver goes to the genetic material. It works its way into the tightly coiled structure of bacterial DNA and inserts itself between the base pairs that make up the code. The strands tangle. The instructions for replication become unreadable. The cell cannot divide, cannot repair damage, cannot pass its information forward. Everything that made it a living organism is compromised simultaneously at 3 separate levels: membrane, metabolism, and genetics, all at once. There is no redundancy that survives this. There is no backup system to switch to. Now here is the part that genuinely surprised researchers when they discovered it. When the cell finally dies, the silver does not die with it. The ions that caused all of that damage remain inside the collapsed structure of the dead cell. And when that cell eventually breaks apart and its contents disperse into the surrounding environment, the silver is released again, still active, still charged, still looking for the next target. One dead cell can seed the destruction of dozens of its neighbors. The process does not stop when the first organism fails. It continues outward in a slow, methodical wave, using its own casualties as distribution points. Bacteria have had millions of years of evolutionary pressure to develop resistance to almost every chemical threat they have ever encountered. They developed resistance to penicillin within years of its introduction. They developed workarounds for tetracycline, for vancomycin, for entire classes of modern antibiotics. Evolution is fast and relentless when the selection pressure is high enough. But bacteria have not developed meaningful resistance to silver, not in millions of years of exposure. Because you cannot evolve a cellular workaround for a process that attacks the fundamental chemistry of what it means to be alive, silver does not target one specific protein or one specific pathway that a mutation could reroute around. It attacks the basic architecture of the cell from 3 directions at once. There is no version of a bacterium that is structurally immune to that. It would have to stop being a bacterium entirely. This is why the observation that keeps showing up throughout history, across cultures that had no contact with each other, is so striking. The detail that water kept in silver containers stays fresh, that wounds treated with silver heal without festering, that households using silver vessels had lower rates of certain illnesses. These were not superstitions. They were accurate observations of a real antimicrobial effect, recorded by people who had no framework to understand what they were seeing, but enough empirical sense to keep doing what worked. The knowledge was real, even when the explanation was missing. But the same chemical aggression that makes silver so effective against bacteria raises an obvious and uncomfortable question. If silver ions can disrupt the proteins of a bacterial cell membrane, what exactly is stopping them from doing the same thing to your cells? You are also made of proteins. Your cell membranes also rely on precisely structured chemistry to function. Your respiratory enzymes also contain sulfur. The answer is that your body is larger, more complex, and has multiple defense systems that a single-celled organism lacks. Your immune system, your liver, your kidneys, all work to intercept and sequester silver before it reaches critical concentrations in sensitive tissues. You can tolerate low-level exposure in ways that bacteria simply cannot. But tolerate is not the same as process, and sequester is not the same as eliminate. And this distinction is where the story of silver takes its darkest and most personal turn. Because silver that enters your body does not leave. It finds places to hide. And what it does once it settles in is something that connects directly back to everything we already said about photography, about latent images, about the way silver transforms under light. The connection between what happens on a strip of film and what happens inside human skin is not a metaphor. It is the same chemistry, happening in a living body, permanently. Your body, when it detects elevated silver levels in the bloodstream, does what any defense system does when it encounters something it cannot neutralize. It removes the threat from circulation and stores it somewhere it can do less immediate damage. The primary storage location turns out to be the skin, specifically the deep structural layer beneath the surface, where silver ions combine with sulfur and chlorine compounds already present in the tissue and form microscopic crystite clusters embedded in the collagen fibers. They sit there, stable, invisible, harmless in the dark. Then you go outside. Ultraviolet light from the sun penetrates the transparent outer layer of skin and strikes those embedded silver compounds. And the photochemical reaction that we described when we talked about how a photograph develops, the conversion of silver salt into metallic silver clusters under the influence of light, happens in your dermis. The clusters darken. They turn from colorless to gray to blue, to a shade that in severe cases approaches the color of a deep bruise that never fades. And unlike a bruise, this one has no resolution. The silver is woven into the structural collagen of your skin. It is not in the blood where a filter could catch it. It is not in the organs where a treatment could reach it. It is in the architecture of your body, and it is not going anywhere. The condition is called argyria, and the most striking thing about it, medically speaking, is that it is not painful. There is no fever, no inflammation, no organ failure from the discoloration itself. You are not sick in the conventional sense. You are simply changed, permanently and visibly and completely without recourse. The discoloration spreads uniformly across the skin as exposure continues, and once the threshold is crossed, there is no laser, no chemical treatment, no medical procedure that removes it. Dermatologists who have studied the condition describe it in terms that sound more like material science than medicine. The silver is not deposited on the skin, it is incorporated into it. There is a difference, and the difference is everything. There is a case that medical literature returns to often when discussing argyria. A man in the American Midwest who spent several years consuming large daily quantities of homemade colloidal silver, convinced that he was protecting his immune system and treating a chronic skin condition. He documented his own transformation in photographs taken over the course of months. The early images show a pale, unremarkable complexion. The later images are genuinely difficult to look at without a second take. His skin had turned a uniform steel blue, darker in sun-exposed areas, lighter where clothing had shielded him. He gave interviews. He appeared on television programs where hosts struggled to respond normally to his appearance. He was not in pain. He was not cognitively impaired. He was simply, permanently, a different color than he had been before. A living photograph of the decision he had made. And this case, as dramatic as it is, represents an extreme of deliberate and prolonged consumption. But the milder version of silver accumulation has a history that predates the internet wellness industry by several centuries. And when you trace it back to the aristocratic households of early modern Europe, to the families who ate from silver plate every day for generations, the implications are quietly extraordinary. Because the pale, slightly bluish complexion that characterized the nobility of that era, the skin tone that painters depicted and that was considered a mark of refinement and gentle birth, was almost certainly not a natural variation. It was chemistry. It was silver, consumed daily in microscopic doses from utensils and vessels, accumulating slowly in the skin over a lifetime, giving those families a distinguishing physical appearance that set them apart from the tanned, weathered complexions of people who worked outdoors and ate from wood and clay. Their pallor was not inherited, it was acquired. Their blue blood was not a metaphor for ancestry. It may have been a literal description of what was happening beneath the surface of their skin. The thing that marked them as separate, as elevated, as belonging to a different order of human being was a symptom. A very slow, very gentle, very permanent form of exactly what that man in the Midwest experienced. Silver does not care about social class. It processes everyone according to the same chemistry. It just took us a very long time to understand what we were actually looking at. But Argyria, as strange and irreversible as it is, affects individuals who consume silver directly. The next problem we created with this element is not personal, it is planetary. And we created it not through ignorance, but through a very specific kind of carelessness that comes from knowing something works and scaling it up without asking what happens at the edges. We are running out of silver. Not slowly, not in some distant theoretical future, but within the lifetime of people who are alive right now. And the reason we are running out is not because we are using it wisely, or storing it carefully, or building things meant to last. We are running out because we are throwing it away. Deliberately, systematically, at industrial scale, in pieces so small that no recycling technology on Earth can recover them cost-effectively. We took the most efficient conducting material in the universe, the shrapnel of colliding neutron stars that took billions of years to arrive on this planet. And we are grinding it into dust and burying it in landfills. Let me give you the scale of this. Every smartphone contains roughly 1/5 of a gram of silver. That sounds negligible until you multiply it by the number of active devices in the world, which runs into the billions. Add laptops, tablets, televisions, medical equipment, industrial sensors, and the number climbs further. Add solar panels, each of which requires a significant quantity of silver paste to function, conducting electricity from the surface of the panel into the circuit with the efficiency that only silver can provide. Add electric vehicles, which use more silver per unit than conventional cars because the battery management systems, the sensors, the motors, all demand conductivity that cheaper materials cannot reliably deliver. The total annual consumption of silver by modern industry is enormous and growing every year, accelerating precisely as the clean energy transition gains momentum. And almost none of it comes back. Gold gets recycled because it concentrates in forms large enough to recover economically. A gold ring, a gold bar, a gold circuit board with enough metal to justify the process. Silver in electronics is different. It is used in layers measured in microns, in alloys and adhesive pastes bonded to other materials, in ways that make separation technically difficult and economically pointless. The silver in a discarded circuit board is real. It is there, but extracting it costs more than the silver is worth at current prices. So it goes into the waste stream, into the landfill, into the ground, where it sits not as a stored resource, but as a dispersed contaminant, thinning out across the soil and groundwater in concentrations too low to collect and too persistent to ignore. Geological surveys that track commercially viable silver reserves have been producing estimates that tighten every few years. At current and projected rates of consumption, the window of accessible supply is not measured in centuries. It is measured in decades. We are not approaching a distant limit. We are moving through it right now, in the middle of a technology boom that demands more silver every year than the year before. Mining from deposits that are becoming harder to reach and more expensive to extract as the easier ones are exhausted. And here is the specific absurdity that sits at the center of this. The green energy revolution, the global project of replacing fossil fuels with solar and wind and electric transport, the effort that is supposed to secure the long-term future of human civilization, is being built on a material whose long-term supply is not secured. Solar panels need silver. Electric vehicles need silver. The smart grid infrastructure needed to distribute renewable energy needs silver. We are attempting to build a sustainable future using one of the least sustainable inputs available. And the rate at which that future demands the material is accelerating faster than any substitution technology is developing. Copper cannot replace silver in these applications without significant performance losses. No laboratory material currently in development has cleared the bar at scale. The element that performs best is the element we are consuming fastest. That is not a political problem or an economic problem. That is a physics problem, and physics does not negotiate. Think about what this trajectory actually looks like from the outside. A civilization discovers the most efficient conducting material in nature. It spends centuries using that material in ways that destroy it, dispersing it into forms that cannot be recovered. Then it builds an entire new energy infrastructure that depends on the same material at accelerating rates. Then it runs projections and discovers that the supply is finite and the timeline is tight. And then it continues anyway, because the quarterly returns look acceptable and the crisis is far enough away that it belongs to someone else. This is not ignorance. The data is available to anyone who looks. This is something closer to collective sleepwalking. A civilization that can see the wall it is walking toward and has decided that looking away is more comfortable than changing direction. The silver in the ground is not going to regenerate. It is not a crop that can be replanted or a fuel that can be synthesized. It formed in a kilonova billions of years ago, drifted across space, arrived here by chance, and was deposited in concentrations that took geological time to accumulate. We cannot make more. We cannot find a substitute that matches it. We can only use what exists, and the way we are currently using it virtually guarantees that most of what remains will end up dispersed beyond recovery within a time frame that is uncomfortably short. And when that moment comes, the consequences will not announce themselves dramatically. There will be no single event, no obvious threshold crossed. The change will be gradual and cumulative. Solar panel efficiency will plateau as silver paste formulations become more dilute. Electronic components will run hotter and fail more often as silver contacts are replaced with inferior alternatives. Medical devices will become more expensive and less reliable. The clean energy transition will slow, not because the political will collapsed or the technology failed, but because the specific material that makes it work efficiently became too scarce and too costly to use at the necessary scale. Progress will not stop. It will just become slower, more expensive, more prone to failure, and less able to deliver on the promises being made right now in every major capital on the planet. We started this story standing in front of a mirror, a puddle of water, then polished stone, then a sheet of glass backed with 500 atoms of silver. The clearest image of yourself you have ever seen, produced by a material that rejected your reflection back at you with perfect efficiency. That image felt permanent. It felt like something that would always be there when you needed it. But mirrors age. The silver coating on a mirror does not last forever. Moisture creeps in at the edges. The metal begins to oxidize in patches. Dark spots appear, then grow, then spread until the reflection becomes uneven and the image begins to distort. The mirror does not announce that it is failing. It just gradually becomes less capable of showing you the truth. And at some point, you realize that what you are looking at is no longer accurate, no longer clear, no longer reliable. And by then, the damage is already done. That is the most honest description I can give you of where we are with silver. Not at the moment of failure, not even close to it yet, but somewhere in the process of letting the edges corrode while continuing to rely on the center as if the edges do not matter. The material that gave us the clearest view of ourselves, literally and technologically, is being consumed in ways that are quietly making that view less clear, less accurate, less available to the people who will come after us. Silver is not just a metal. It is the physical record of a catastrophe that happened before our world existed. It is the material that let us see our own faces clearly, preserve our memories in atomic structure, transmit our thoughts across continents, and attempt to power our civilization without burning the atmosphere. It is the element that exceeds every standard humans built to measure excellence. And we are treating it like a consumable, like something with an infinite supply and no consequence of loss. like something that will simply be replaced by the next thing, even though no next thing exists. The universe spent billions of years producing the conditions for silver to form, and then billions more years delivering it here. We have had it for a geological eye blink. And the question that I keep coming back to, the one I cannot answer and cannot stop asking, is this. If we cannot manage to protect the rarest and most useful material on the planet even when we fully understand what it is and where it came from, what exactly does that tell us about our ability to protect anything else? Write your answer in the comments. I am genuinely curious what you think. And if this story changed the way you see that silver coating on your mirror, or the contacts inside your phone, or the solar panel on your neighbor's roof, hit the like button and subscribe. There is a universe of material like this waiting, and we are just getting started.